Ramesh, can you show me how interrupts actually work?
So we've seen all the underlying concepts for interrupts.
But I want to know how it actually works.
So you want to know what the flow of
Yes.
things is when we run interrupts, right?
Yes.
So let's take an example, a concrete example. We're going to use Sysdig as an example, right? So we've enabled Sysdig. We've made sure we armed it, enabled it, and we've turned on all the interrupts. So we're just waiting. We turn on the interrupt, so the I bit is set, and now your main program is running. So here's an example. We're gonna run periodic Sysdig. We have a main program. We've initialized our clock. We have this Sysdig arm is being set up so that it's gonna interrupt the period is being set and it's a priority. We know how to do all this. It's been armed and ready to go. We've enabled our interrupts. We're sitting here on line 39, John. So we're right there on line 39. The program counter is right here. Break it down into assembly instructions. What needs to happen is, as part of getting our interrupts working, we did one very important thing, which is we set up the interrupt vector table.
Ooh, what's that?
So our interrupt vector table is a table of pointers or addresses of routines, right? We know that the interrupt vector table resides at 0x00000004. That's where it starts. And for every interrupt in our system, there is an address here. So every 4 bytes here make up an address. There's another one at 8 and so on. So somewhere here there's a address that corresponds to our particular interrupt, which is Sysdig. So every interrupt has an interrupt number. We call that a vector number. That's why we call them vectored interrupts. So this interrupt vector table has one address per interrupt. So the Sysdig happens to have the interrupt number. If you count from here, if it's 0, 1, 2, interrupt 15 is Sysdig. And so the 15th entry in our table corresponds to Sysdig. So here there is a label that I put, or an address I put, and the address is the handler I want to run.
So is that the handler or just an address?
That's an address. So that's the address. So the interrupt vector table holds addresses of routines, subroutines, to run when the corresponding interrupt is triggered. So John, what is a trigger for Sysdig?
Yeah, when Sysdig counts from 3, 2, 1, when it goes from 1 to 0, it triggers an interrupt.
So 1 to 0 transition is our trigger in the case
For
of Sysdig, right?
Right.
So what should happen then is if I'm executing this line, which is basically setting the red light on, right? It's toggling it because I'm taking that. It sits here, it keeps doing this. At any point you press when the Sysdig goes off, a routine runs, and the routine that runs has this exact label.
Yeah, but how did I get there?
How did it get there? The magic is in
Do
your
I call
table.
it? Does
No.
the software call it?
Yeah, it happens automatically.
Ooh.
And the automatic is because there's a table, which is our table right here, which is called the Sysdig table, and our interrupt vector table. And if you notice, this table has entries in it. I'm not going to copy all of them. We'll just look at some of them, right? And that's what is sitting here, right there. That's what is sitting there. And one of those entries, as we said, is our Sysdig handler.
There it is.
That's the handler, and that happens to be our 15th entry of our system. So, and it's already hardwired into our code, right? It's hardwired into the code because it sits in this file, and this file, which you can find, by the way, in every project, there's a tclang folder, and under that there's a file called the startup. This startup file has all the information, and one of the information that needs to be loaded at the startup of your program, and one of them is your handler list of handlers. And so we just loaded that.
Well, look at
and-
them all.
And
Woohoo!
that's the name right there.
Yeah, that's the one.
Now, if
Oh, are we going to learn all these interrupts in this class?
we'll learn some of them,
Some of them, all right,
some
because
of
that's
them,
a lot of them.
but
Look
not
at 'em
all. Actually, you get a sense for, if you learn one interrupt, you learn them all in
Oh,
some
okay.
ways, because they
That's
all
awesome.
work through our interrupt vector table.
Cool.
So that's pretty much it. So if I were to run this code, the instant an interrupt occurs, it'll come to this line. So if I were to put a breakpoint here, then it'll come and reach that line.
Sweet. And it gets the address from that vector table.
It gets the address from the vector table.